Hey y'all. Okay, so I kind of just realized that this platform continues to record even after right here where it says stop sharing your screen. Even after I select that, it's still recording. So I'm very confused. But, anyways, I'll just have to, I don't know. What am I doing? Okay, so this is going to be 13.1. This is going to be part two. Part one, what we did was, let me hit hide. What we did was we just did another factoring example. And then I just showed y'all that there's also a way of going and like doing a factor tree, looking to see what the common factors are. And then we looked again at how to find the common variables, which is going to be, of course, you have to have that variable in common, obviously, right? And then you'd pick the one that has the smallest exponent. And then even if you have a pair of variables with all different kinds of exponents, or if you have a trio of variables, like you just have to make sure that they all share that same variable, because of course it has to be in common, right? So I've got three different examples right here. And the two that we're going to start with are binomials and pulling the GCF. And then the third one we're going to do is going to be a trinomial, and we're going to pull the GCF. And then for our third video, we should have more. Oh, there they are. Okay. For our third video, what we're going to do is actually do the factor by grouping method. I just think that doing all of these different little chunks and kind of leading up to factor by grouping hopefully like reinforces the process that we're doing. Okay. So let me go ahead and flip my laptop so that I can get started. Let me zoom in some. Okay. So for the first example, y'all, the directions just say factor. Okay, they don't really say anything else, just factor. So you're supposed to be able to look at the problem and know, like, oh, okay, this is what I do. Okay, so I'm going to show you this one forwards and backwards. Okay, so the problem we're going to do is 5x plus 30, maybe 5x plus 30. It tells me to factor it. Okay, so what I'm going to do is I'm going to look and I'm going to look at the coefficients, see what they have in common, look at the variables, see what they have in common. When I look at 5 and 30, there really shouldn't be any need to go and do prime factorization. 5 is already prime, and so I actually don't take prime factorization of a prime number, right? Because the only factors are 1 and 5. And then for 30, I know that 30 can be divisible by 5 because it is divisible by 5, right? It can be divided by 5. And that's actually the largest thing that they have in common. So I would just pull out, I'm using quotes, you can't see me. I would just pull out my 5, right? Now I would look, do all of the terms have an x? No, because they all don't share that common variable, it cannot be a part of the greatest common factor, okay? Here, what I do is I'm just going to divide both of these terms by the GCF, okay? So literally, I'm going to take 5x and I'm going to divide it by 5. Well, 5 divided by 5 is 1. X divided by no x is just x, right? So that goes here. Then now let's go ahead and divide 30 by 5. That's a positive 30, right? So you got to make sure you pay attention to that. If it's a negative, you always want to bring it down, okay? So here I do 30 divided by 5 is 6. Signs are the same, so it's positive. So it's a positive 6. That's it, right? You just factored that binomial. Now what I meant by I want to do it forwards and backwards, that binomial, we found what they had in common and we pulled it out, doing more air quotes, y'all. And technically what that means is you take however many terms you have and you divide it by your GCF, right? Whatever you have in your parentheses, those number of terms should match your original problem. I had 2 terms, I divided 2 terms, so inside of my parentheses, I still have 2 terms. Yes, babe. Okay, so what I'm going to do now is I'm going to go the other way, right? That was division. Now I'm going to actually show you if I distribute this 5 back in, you do 5 times x. Well, that's 5 times 1 is 5. Signs are the same, so it's positive, right? No x times x. That's still just x, right? Then we would do 5 times 6. You get 30. Signs are the same, so it's positive. Do you agree with me that 5x plus 30 is the same as 5x plus 30? Right? So that's what I mean by forward and backwards. I feel like the beginning of the chapters, what we would do is we learned this distribution, right? We saw that there was something next to a parenthesis and we knew, hey, I need to distribute that inside of it. I need to multiply everything by this number, right? Now, going this way, we have our 5x plus 30, and it's actually telling us, okay, so they have something in common, pull it out. And we're turning it into a multiplication problem, right? And so that's why it's called factor, because this is called a factor. And whenever you multiply things, the two things that have been multiplied together are the factors that you use to get back to your original thing. That would be the actual product. So hopefully that kind of makes a little bit of sense as far as like why this division even works and why we have to make sure that we only pull out what they have in common. Because if we don't, and then we try to go back and do this multiplication, we won't get back to the original answer. Okay, so let's do these 2 more examples for this video, maybe. Okay, so the second one is 28x to the 5th y. And then we have a positive 12 x to the 6th y to the 7th, right? So this is what I meant as far as like having all these different variables. But it really doesn't matter how crazy the problem looks because you're still going to do it in bits and pieces the way I've showed you, where you look at the coefficients, see what they have in common, then you look at each individual variable, see what they have in common. Is everybody going? Dalton too or no? No? So Alyssa, Aiden, Cameron, Caden, Manny? Okay. Love y'all. It's already dark, so I don't want y'all going long. Okay, so we look at 28 and we look at 12. Just kind of doing this in a trial and error way, y'all. I know that they're both divisible by 2, but those are fairly large numbers. I know that 7 can go into 28, but it can't into 12, right? 6 can go into 12, but 6 can't go into 28. After you do so many trial and errors and you're like, I'm really not sure. This is one of the examples where we can go ahead and factor 28 like this and 12 like this. You could also do prime factorization, okay, whichever way is easier for you. I think I might be partial to this. Ow. Why did I do that? Okay, sorry. Oh, that was another example. I'm looking at what I did. I'm like, that does not look right. If it's because I used I wrote in the wrong spot. So here I get 1 and 28, 2 and 14, 4 and 7, right? That's it. 1 and 12, 2 and 6, 3 and 4. Okay, what do they have in common? The largest one, right? Greatest common factor. I think whenever I told you earlier, I said to multiply them if they have them in common, and that was actually a complete mess up on my part. Let me do prime factorization to show you why we don't. So now this problem just got really long for no reason because I misspoke. 12, 2 and 14, 2 and 7, right? 2 and 6, 2 and 3. So 13.1 video. Now I just feel like I need to re-record it. I had said that you have this option or you have the factor tree option. Here, right, prime factorization, if you have multiple factors, you multiply them together, right? That's how you get what your GCF is. For here, you only find the largest one they have in common. I gave you the directions for this and I applied it here and that was wrong. Okay, I said if you have more than one, you multiply them together. That's not correct, right? Because if I multiplied what they have in common here, what do they have in common? They have a 2 in common. They have a 4 in common. What do I get? I get 8. Does 8 equally divide 12? No, like you get a decimal, right? So I combined the rules in a way and I apologize. What I'll do is probably add like a note on my YouTube video. We'll see how that works. Okay, so now looking at the factor tree, greatest common factor, greatest, largest, biggest is a 4, correct? Looking at my prime factorization, y'all, what do they have in common? They both have a 2. And then look, they both have another 2. Here is where if they have more than one thing in common, you multiply them. What do I get? I get a 4, which is the same as that 4 right here. Okay, so I apologize. I'm going to go ahead and delete this prime factorization right there. I have what my greatest common factor is for the coefficients, which is 4. Now let's look. Do each term contain an x, right? And they both have an x. Which one has the smallest exponent? That would be the 5. Does each term have a y? Yes. What's the smallest exponent? 1. So you just write that. This is the greatest common factor. Now what you do when you pull out the greatest common factor is you divide. I deleted the prime factorization so that I could divide each of these right here individually by my greatest common factor. 28 divided by 4 is 7. X to the 5th divided by x to the 5th, those cancel, right? It becomes 1. And then y divided by y, those also cancel. It becomes 1. 7 is going to be the only thing I have written there. And because those are both positive, it's a positive 7. Now if we do 12x to the 6th, y to the 7th, divided by 4x to the 5th, y, 12 divided by 4 is 3. X to the 6th divided by x to the 5th. Exponent rule says keep and subtract your exponents. You get x to the 1st. And we do y to the 7th divided by y. Y to the 7th divided by y is keep and subtract, right? And because the 12 and the 4 are positive, my 3 is positive. That ends up being the final answer. I can't believe I misspoke on the other email. I mean, the other video. Can't say anything right now. It's going to get like under my skin. Okay, so I'm not going to actually go the other way with this one. I'm just going to show you, y'all. If you do 4 times 7, you get 28. They're both positive. 28 is positive. X to the 5th times no x to the 5th is x to the 5th. Y times no y is y, right? Now if we do this times this, 4 times 3 is 12. Signs are the same, so it's positive. X to the 5th times x is keep and add. You get x to the 6th. Y times y to the 6th, keep and add. You get y to the 7th, right? That's a way that you can check if, oh my gosh, that's the way that you can check to see if you pulling out the greatest common factor was done correctly. Okay, so let's do this last example. What do I have written here? A negative. Okay, I did this one for a reason. I think this one's really important, okay? So for the third example, what we have is a negative 25 x cubed plus a 40 x squared plus a 15 x. Okay, so looking at all of these terms, I noticed that, okay, since 2 of them end in 5 and 40 ends in 0, that lets me know that 5 can divide all of them, right? And then 15 is only 1 and 15 and 3 and 5. Those are the only factors. And 3 won't equally divide 40, and 3 won't equally divide 25. So I'm just going to go ahead and believe that 5 is going to be my greatest common factor. The reason why I did this example, y'all, when your leading coefficient, when the number in the front is negative, that negative sign has to be pulled out and included with, put in front of your GCF. So I know 5 is the largest number that'll divide all 3 terms. Because my leading coefficient is negative, my 5 is negative, okay? And so now what we do is we're just going to go ahead and divide after we see if they have any x's in common. So you ask yourself, do all of the terms have an x? Yes. What is the smallest exponent? And that would just be x to the first power. So that's going to be my GCF in its entirety, y'all, is negative 5x. Now we divide. So let's come right here and let's divide. This is the first term. divided by the GCF. 25 divided by 5 is 5. Signs are the same, so it's positive. X cubed divided by x would be keep and subtract. I get a 5x squared. Then we do 40x squared divided by negative 5x. 40 divided by 5 is 8. Signs are different, so it's negative. X squared divided by x is x, right? Keep and subtract. And then we have 15x divided by negative 5x. 15 divided by 5 is 3. Signs are different, so it's negative. X divided by x, that goes to 1, right? Negative 3 times 1 is just negative 3. So I didn't write this one, negative 8x, and then now my negative 3. If you go back and you multiply our GCF to everything we got here when we did our division, you will get back to this original polynomial. Okay, so I'm going to take like a 5-minute break before I do video 3 because I've already said like 4 things wrong. If y'all have questions, though, of course, make sure you ask, okay, just like always. Thanks. Bye.